So hello everybody, welcome to this important series of constraint motion. So these are the 12 problems which we will be solving in this series. So this series will be consisting on the entire idea of establishing constraint relation between 2 points, 2 blocks, or a combination of such systems. So welcome to the first problem of this series of constraint motion, where a rod is kept against a vertical wall and a horizontal floor. So if the lowest point or the point on the horizontal floor is having a velocity u, we need to determine the velocity v of the point which is against the wall. So let's get started with this problem. So in order to solve this, we are considering that if this distance is equal to y, where the distance y is on the y-axis or on the vertical wall, and if this distance is x, where x is the distance on the x-axis or the horizontal floor. So over here the first equation which we can write is that as this stick is going to slide, this point is going to come down slowly and this point is going to move away on the x-axis direction. So we can write this aspect that u is equal to dx by dt. So point u is equal to dx by dt and point v is equal to dy by dt. And since y is decreasing with time, since y is constantly decreasing with time, so we are writing dy by dt as minus v or minus dy by dt is equal to v. So we can either way write this expression. Now the next aspect which we need to find out is what is connecting the relation x and y. So x and y are connected by a parameter which is the length of the rod. So the length of the rod is constant in this problem. So if the rod slide along x, along y, or in the combination, the length L is constant, and hence we can write a relation between x, y and L, and the relation which we can write is x square plus y square is equal to L square, following the Pythagoras theorem. Now since we have the term as dx by dt and dy by dt, so we can say over here that if we differentiate with respect to time, so on differentiating with respect to time, so we get the expression 2x dx by dt plus 2y dy by dt is equal to derivative of L square, L being constant, will be 0. So L is not changing with time, so we get a term 0. So from this expression we can definitely write that x times of dx by dt is equal to minus y times of dy by dt, where dy by dt is velocity v which we are looking for with a negative sign, and dx by dt is u. So x times u is equal to y times v. So v can be written as u times x by y, where x by y can be written as cot theta. So we can say v is equal to u cot theta, and this is the final answer for this particular problem, that v is evaluated in terms of u and theta, that v is equal to u cot theta. But I have a method too to solve this problem. So whenever in the initial stages we are solving the problem of constraint motion, I am going to tell you two methods, and gradually we will stick to the second method, which is the faster method of solving the problem. So let us look into method 2. So for method 2, let me give you a logic before we start the method 2 problem. So if I consider that we have a rod kept in a vertical plane like this, and if the front end of the rod is having, say, velocity 5 meter per second in the x direction, which is equal to u, so the rear end of the rod must also be moving with a speed of 5 meter per second, that is equal to u, because the length of the rod is constant. So if the front part of the rod is moving faster and the rear part of the rod is moving slower, then definitely the rod will grow in size. Or if the rear part is moving faster and the front part is moving slower, then the rod will become shorter with time. So since it is not the case, so the component of velocity along the length of the rod must be constant. So this is the logic which we are going to use when we are solving using method 2. So over here in this diagram, if we break the component of u, so this point is moving with u in the horizontal direction. So along the length of the rod, the component will become u cos theta. So this component will become u cos theta, and if it is moving with v, and if this angle is 90 minus theta, so the component of v along the length of the rod will become v cos of 90 minus theta, that is v sin theta. Now using the logic which we have established earlier, we can definitely say that v sin theta is equal to u cos theta, and therefore v is equal to u cos by sin, that is cot theta. So this method was faster than the previous one and do not involve much use of differentiation or much use of establishing 2 or 3 relations between the points x and y, and hence gradually we will try to shift to method 2 while solving these 12 problems. So let us move on to the next video where I will be showing you to solve problem 2.